While the world watches rockets launch to the moon and Mars, a new, more dangerous space race has already begun in the shadows. Directly over the North Pole, Russia is planning an orbital fortress. It's not a science lab. Roscosmos, Russia's space agency, has announced its new station. The Russian Orbital Service Station, or ROS, will be placed in a high-inclination polar orbit. It's a move that analysts see as signaling a clear, strategic military purpose over a purely scientific one. At the same time, SpaceX is surrounding the globe with a shield of thousands of satellites. For the US military, a system known as Starshield. This isn't just about two competing space systems. This is a fundamental clash of military doctrine. The immovable object versus the irresistible force. An old-world philosophy of a centralized, powerful bastion, pitted against a new world philosophy of a decentralized, resilient network. And the winner of this doctrinal conflict could very well decide who controls the next frontier of warfare. For decades, the strategic high ground in space was geostationary orbit, where satellites match Earth's rotation and appear fixed in the sky, perfect for communications and missile warning. But the board is changing. The Arctic, once a frozen wasteland, is now a theater of intense geopolitical competition. Melting ice is opening new shipping lanes, like the Northern Sea Route, and exposing vast, untapped natural resources. For a nation like Russia, with its long Arctic coastline, controlling this region is a paramount national security interest. This is where orbital mechanics becomes military strategy. A traditional space station, like the ISS, flies at a moderate 51.6-degree inclination. That covers a wide swath of the planet, but it never passes over the poles. To watch the Arctic, you need a polar orbit. A satellite in a near-polar orbit travels north and south, and as the Earth rotates beneath it, it can observe the entire surface of the planet over time. This is precisely the kind of orbit Russia has planned for ROS. Public plans often describe a sun-synchronous orbit, which means the station passes over a given spot at the same local solar time each day, providing consistent lighting for observation. Perfect for monitoring naval movements, military bases, and that strategically vital Northern Sea Route. However, the final orbital parameters are not set in stone. Other options have been considered to best suit Russia's launch sites and objectives. This specific orbital choice would give Russia persistent surveillance over not just its own territory and the Arctic, but also the northern regions of the United States and Canada. The flight paths for intercontinental ballistic missiles. It is, in effect, setting up a watchtower on the roof of the world. But this choice comes with big challenges. Reaching polar orbits is more difficult for launch sites not near the poles, as they can't take full advantage of the Earth's rotational boost. Russia, however, can use its northern PlaceX launch site, which is better optimized for these kinds of launches. More critically, these high-inclination orbits pass through areas of higher radiation, like the South Atlantic anomaly, posing risks to electronics and human health. This is one of the stated reasons ROS is designed to be capable of autonomous, uncrewed operations for long periods, limiting cosmonauts' radiation exposure and cutting costs. The decision to accept these risks underscores the strategic value Russia places on this orbital real estate. It's a clear signal that ROSS is not just a successor to Mir or its role in the ISS. It's being designed as an instrument of national power. Russia's approach to space has always been colored by its history. From the powerful, heavy-lift rockets of the Soviet era to the robust, simple design of the Soyuz spacecraft, Russian engineering often favors centralized, powerful, and durable systems. The Russian Orbital Service Station, or ROS, is the modern heir to this doctrinal lineage. It represents what you might call a fortress strategy in space. The plan for ROS, scheduled to begin construction around 2027, involves a modular design that could grow to 7 modules by the mid-2030s. But its purpose appears fundamentally different from its predecessors. While Roscosmos also highlights scientific and commercial goals, the station's capabilities have clear national security implications. For example, plans call for ROS to have the ability to service and even deploy other spacecraft. This takes on a more ominous tone when you consider what the Pentagon alleges are Russian inspector satellites, like Cosmos 2576, which it believes is a counter-space weapon capable of attacking other satellites. A large, crew-capable station in a strategic orbit, equipped with robotics, refueling capabilities, and the ability to deploy smaller satellites, becomes a formidable military asset. In theory, it could function as an in-orbit command center, a reconnaissance platform, and a mothership for anti-satellite weapons. This is the essence of the Fortress Doctrine, a single, high-value, multi-purpose asset designed to exert control over a specific domain. There was also ambitious talk about pairing the station with the Zeus nuclear-powered space tug. A megawatt-class reactor in space could hypothetically power potent sensors, directed energy weapons, or jammers, turning the fortress from a watchtower into an active enforcer. However, that concept appears to be on ice. The Zeus project faces major financial and technical hurdles and may be canceled or significantly scaled back. But the Fortress Doctrine carries a massive, inherent weakness. By centralizing so much capability into one platform, Russia is creating a huge target. A single, successful anti-satellite strike could neutralize a multi-billion-dollar strategic asset. It's the space equivalent of putting all your eggs in one very large, very expensive, and very tempting basket. This strategy is brittle. It has limited redundancy. If the fortress falls, Russia's ability to monitor the polar corridor would be severely degraded. This stands in stark contrast to the emerging American doctrine. If the Russian strategy is a fortress, the American counter-strategy, embodied by SpaceX's Starshield, is the network. Starshield is a military-focused satellite system spun out from the commercial Starlink constellation. Announced in late 2022, it's designed for government use with a focus on 3 key areas: Earth observation, secure communications, and hosting government payloads. The US government is already all in on this concept. SpaceX has secured a reported $1.8 billion classified contract with the National Reconnaissance Office, NRO, for a network of hundreds of spy satellites. It also has a $70 million contract with the Space Force for Starshield's secure communication services. These satellites provide everything from high-speed encrypted comms for troops to advanced sensors for tracking things like hypersonic missiles. The engineering doctrine here is a whole different game from Ross. Instead of one large, exquisite, and expensive asset, Starshield relies on a proliferated, low Earth orbit architecture. This means deploying hundreds or even thousands of smaller, relatively inexpensive satellites. This is the network strategy, and its defining feature is resilience. You can't disable the network by taking out one satellite, or even dozens. The system is designed to fail gracefully. If one node is lost, traffic simply reroutes through others. This is a distributed system, and history is littered with examples of single, monolithic satellites failing and causing major disruptions. A distributed network, by contrast, has built-in redundancy. SpaceX's incredible launch cadence allows for rapid replenishment of the constellation, meaning any disabled satellites can be replaced faster than an adversary could likely take them out. This creates a strategic nightmare for any potential aggressor. The cost of trying to deny the network becomes prohibitively high. However, the network isn't invincible. While physically resilient, a distributed network is heavily dependent on software and cybersecurity. A successful cyber attack could potentially be more devastating than a physical one. Plus, the system relies on commercial infrastructure from a private company, which creates complexities around government control in a crisis. The lines between the commercial Starlink and military Starshield networks can appear blurry, with the military leveraging the architecture of the civilian one, creating potential entanglements and shared vulnerabilities. The US military is betting that the resilience gained from mass and replenishment outweighs the risks of cyber threats and commercial dependence. When we put Ross and Starshield side by side, we aren't just comparing hardware. We're comparing two totally different philosophies of power in the 21st century. It's a clash of doctrines that reveals how two global powers think. First, let's look at resilience. This is the most glaring difference. Ross, as a single fortress, is inherently brittle. Its defense relies on hardening it against attack. But if those defenses are breached, the entire investment and its strategic capability are lost. Starshield, the network, is designed for resilience through numbers and replenishment. It can absorb losses and keep functioning, making it a far more survivable system in a fight. Next, capability. Ross aims for centralized, high-end capability. If it were ever paired with a powerful nuclear source, it could host sensors or other systems far beyond what any single small satellite could manage. It's a space battleship designed for area control and potentially offensive actions, like servicing or disabling other spacecraft. Starshield offers ubiquitous, persistent capability. It's not about one powerful eye. It's about thousands of eyes, providing continuous, real-time global coverage for intelligence and data superiority. Its purpose isn't to occupy a single point, but to provide an information blanket across the entire globe. Then there is cost and replenishment. The estimated cost for Ross runs into the billions, and its construction is a multi-year process tied to Russia's heavy-lift Angara A5 rocket. Replacing it would be a monumental task. Starshield satellites, on the other hand, are mass-produced. While the overall program is expensive, the per-unit cost is low enough to treat them as almost expendable. SpaceX's rapid launch capability means the network can be built, expanded, and replenished at a speed no state-run program can currently match. Finally, this brings us to the strategic goal. The Ross Fortress strategy is about area denial and control. By placing a powerful asset over the Arctic, Russia seeks to create a bastion, challenging American and Allied access to a strategically vital region. It's a classic geopolitical move, translating old ideas of choke points and fortresses into orbit. Starshield's network strategy is about global persistence and information dominance. The goal isn't to deny access to one orbit, but to ensure the U.S. military can see, communicate, and operate anywhere on Earth at any time with an overwhelming information advantage. This clash is a modern-day replay of the battleship versus the aircraft carrier. One doctrine favors a powerful, heavily armored, and centralized weapon system. The other favors a distributed, resilient, and network-centric force. History showed us how that contest ended on the seas. We are about to see how it plays out in the ultimate high ground of space. The parallel developments of the Russian orbital service station and SpaceX's Starshield are more than just a tech race. They represent a deep philosophical split in military space doctrine. Russia, leaning on its engineering heritage, is building a fortress in the sky, a powerful, centralized bastion meant to exert control over a critical choke point. It's a strategy of presence, of tangible power, concentrated in a single, formidable asset. But it is also a brittle strategy, a high-stakes gamble on one high-value target. The United States, leveraging its commercial aerospace dynamism, is weaving a digital web around the planet, a decentralized network designed for resilience, persistence, and information supremacy. It is a strategy that trades the concentrated power of a single platform for the survivability of a swarm. Its strength lies not in any individual satellite, but in the power of the network itself. This Arctic gambit, Russia's deliberate plan to place a military-capable station in a high-risk, high-reward orbit, has set the stage for this doctrinal showdown. Will the future of conflict in space be defined by powerful, orbital battleships like Ross, able to dominate their immediate vicinity, or will it be defined by ubiquitous, resilient constellations like Starshield, vast data and communication fleets that render the battleship obsolete? The answer won't just determine who holds the strategic advantage in the Arctic, but will also shape the very nature of space warfare for decades to come. If you found this analysis of space strategy and engineering compelling, be sure to subscribe and hit the like button. We regularly break down the complex technologies and doctrines shaping the future of defense and geopolitics. Let us know in the comments which doctrinal approach you think will prevail in this new space race.